Usually the much. Okay, why should shuffle be minimized? Well, shuffle. The thing that sucks about shuffle is that it's the bottleneck for parallelism. So if you have a pipeline that doesn't use shuffle, it can be as pretty much as
Can you feel me now? Tell me, can you hear me now?
usually the more parallelism that we can have, the more effectively we can crunch big data, because that is going to be what makes it possible for us to use more machines and to have less bottlenecks. Because shuffle, you can think of shuffle as the bottleneck. It almost always is the bottleneck for if you were working with very high volume data. So there's a couple different ways that we can, think about minimizing shuffle, but we'll be going into that. There's like a modeling way to do it. There's like also like more kind of tactical ways to do it that we'll talk about. So yeah, let's talk more about shuffle. Shuffling is so fun. When you are, yeah, let's kind of big like a specific chunk of data to all be on one machine. You can have it where like all of it split out, and we're going to talk more about like what that means and the parallelism of stuff in another slide. But keeping in mind that like some steps in your big data pipeline are going to have more parallelism than other steps in your big data pipeline. And because of that, like usually the more parallelism that we can have, the more effectively we can crunch big data. Because that is going to be what makes it possible for us to use more machines and to have less bottlenecks. Because Shuffle, you can think of Shuffle as the bottleneck. It almost always is the bottleneck for if you were working with very high volume data. So there's a couple different ways that we can think about minimizing Shuffle. But we'll be going into that. There's like a modeling way to do it. There's like also like more kind of tactical ways to do it that we'll talk about. So yeah, let's talk more about Shuffle. Shuffling is so fun. When you are working with big data, you have in SQL, right? You have a couple different keywords: select, from, where, group by, join, having, order by. These keywords affect Shuffle in different ways. For example, if you have a query that is that just uses select, from, and where, and importantly, your select doesn't use a window function, but so you have select, from, and where without a window function, that is what is considered a query that is infinitely scalable. You could essentially have it where, like, if you think about it this way, like, say you had a billion, let's think about it in like kind of the most extreme sense here, right? So say you had a billion rows and you had a billion machines, and each machine had one row. The thing is like with select, from, and where, that's fine, right? Because one machine doesn't need to have more data or less data, because all it needs to know is like, okay, here's the data I have. Does this data fit this condition or not? And if it does, okay, bring it out. Otherwise, don't bring it out. And that's it. That's all. Like, you don't have to have like a specific chunk of data on a specific machine. That's the big thing to remember about select, from, and where, is that like if you're using those three, like you can go as parallel as you want. And that is very, very powerful if you can understand that fact, because you can use, if you have queries with those three keywords and only those three keywords, like the job is going to essentially come back instantly. The job is going to be no shuffle. The job's going to be cheap. The job's going to be all of those things, right? So now let's talk about the ones in the middle. Here we have group by, join, and having. So why are these not extremely parallel? Well, the main reason for that is because, so say you have group by, right? And let's go back to that example where we have a billion rows and a billion machines, right? And there's one row on each machine. Well, with group by, the problem is like, in order to actually do the right aggregation, all of the rows for that key, so say there's me, and I'm someone who has 30 rows in this billion row data set, right? And all 30 of my rows need to be on one machine. They all need to be moved over onto one machine in order to correctly count them, right? Because if they're all separated and my 30 rows are all on different machines, then how do we know that there's 30? We don't know. Like that's like, and that whole process of collecting, like, so the data is in a bunch of chunks and is all separated out into like this comically chunked out like one row per machine kind of situation. And in that case, we'd have to move all of those into one machine where then it has all 30 rows of data so that it can count at that point. And that's why group by triggers shuffle. And that's what all shuffle is, right? Is shuffle happens when you need to have all the data from a specific key on a specific machine. That's all it is. And so, and that's the big thing to remember when you're doing shuffling. And so that's why group by works in this case, right? Is then you would reshuffle and then